Right. Hello, everyone, and welcome to this session on coding confessions. My name is Colin Soze, and I'm an RSE at Aberystwyth University, and I'll be the chair for this session. Also joining me as co-chair is Irene from the Netherlands. Do you want to quickly introduce yourself?
Sure. Yeah, so my name is Irene. I am from TU Delft in the Netherlands, and for the research data, I'm not an RSE. I train people in research data management and open science.
And also behind the scenes, we have Patricia Hetrick, who's going to be writing down notes that will go up on our blog. This all started out as an idea back in April at the Software Sustainability Institute's collaborations workshop between myself, Irene, Patricia, and Dave Horsfall, who can't be with us today. And our idea was that we wanted to try and create a culture where software developers feel free to talk about their mistakes with each other, and that they won't be judged for making mistakes, because we know that every software developer does make mistakes. And we feel that this is often a thing that contributes to people having imposter syndrome. And it also causes mistakes to be repeated because people don't talk about them. More junior developers don't know that they exist, and therefore they repeat them. So our aim was to write up a blog post for each mistake or confession that comes into us, that allows people to go out there and read these things and hopefully not repeat these mistakes. So today we have with us a panel of 6 experienced RSEs who are each going to give one confession of a coding mistake that they've made at some point in their career. And now I'm just going to have each of them introduce themselves. So first, Magnus, if you can introduce yourself.
Right. Hi, I'm Magnus Acton from the School of Geosciences at the University of Edinburgh, and I've been an RSE for quite a while now and started off with Fortran, and these days I do mostly Python.
Okay, thank you. So next, can we have Yo?
Hey folks, my name is Yo Yehudi. I've worked in and out of academia and research software engineering since about 2013. Before that, I also have worked in industry and retail as a coder.
Thank you. And can we have Ed next, please?
Hi, I'm Ed Bennett. I lead the research software engineering team at the Swansea Academy of Advanced Computing at Swansea University. I've been an RSE since 2017, and before that, I worked in academia as a lecturer and as a researcher in computational particle physics.
Thank you. Can we have Janetta next?
Hi, my name is Janetta Stein, and I'm a senior research software engineer at Newcastle University. I've really been developing software since, I don't know, 1984. It was a very, very long time ago. But I've been working as an RSE since 2019. Before that, I was a research associate. And before that, I did my PhD. And before that, I was in industry.
Thank you. Can we have Becky next, please?
Hi, so I'm an astrophysicist. I'm at Keele University as a postdoc. I've done stuff in and around research software engineering for most of my academic career. It's something I really love. I did a software sustainability institute fellowship, like I imagine quite a few people here have done. Yeah, that's what I'm working on.
Thank you. And finally, but not least, Graham.
Thank you. Graham Lee. I'm a senior research software engineer in computer science at Oxford University. I've been doing that since 2019. And before that, I had an industry software engineering career and an undergraduate background in physics.
Okay, thank you. So this is our panel for today. So I'm going to start going through in the same order and ask each of you to spend about 5 minutes just telling us about one mistake you've made. I know some of you have got slides to help illustrate things. So if we could start in the same order, so we'll start with Magnus again.
Okay, right. So let's see if I can share my slide. Okay, so can you see that?
Yes, we can.
Okay, excellent.
But there is a border around it. I don't know if you want to full screen it.
I guess I can full screen. Can I full screen that? Is that better?
Yes, thank you.
Excellent. Right. Cool. So that's a story from quite a while ago, and I was working on a big Fortran code, and I had to compute the gradient on an irregular mesh. So a quick summary: with a nice regular mesh, it's really easy to calculate the gradient. You might use well, forward and backward differences, and if you take the average, you end up with essentially central differences. So that's nothing sort of unusual, and we all kind of know and love how to do this stuff. So in an irregular mesh, it's a bit more tricky because we don't get sort of connections along the right directions. And so I figured, well, I can do something similar. I use my forward differences, and only this time they're in sort of weird directions according to the connections. And I end up, and I can decompose those directions. So if I take the derivative along the direction I'm considering, I can decompose that into a direction along the x-axis and the y-axis, which is my gradient. And if I do that for all of them, I end up with a nice linear system of equations. It's overdetermined, and I can solve that. So the story is about solving this system of linear equations. And so my first approach was, well, so we have this this system of equations here. My first approach was to use LAPACK. You know, there's a really handy function called DGELS, which solves the solve problem. And because it was a big code, we were already using LAPACK, and in fact, we are using the AMD Core maths library, which is optimized to do this sort of stuff and make best use of the processors, AMD chips, which we're using. So I thought, right, I'm going to use this. And I did. And and I should also say I had to do that for millions of points. So although each problem individually was fairly straightforward, there was a lot of them. And it took forever and ever. Like, it was totally unsustainable. And I looked into it, I traced it, run the profiler, and it turned out that the call to DGLS managed its own memory. It allocated a bunch of memory to solve the problem, deallocated. And that's where all the time was spent. So that was not good. My next approach then was, well, to do a bit of linear algebra. And instead of using a canned function, I used the built-in Fortran routine matmul to square the matrix. And so that improved it, but it was still too slow. And in the end, I just computed B by hand because there's just two unknowns. It's just, I end up with a 2x2 matrix, square matrix, and doing that by hand is really easy because I had all these coefficients as a vector. I can use the sum function in Fortran. And because it's a 2x2 matrix, I can also write down the inverse by hand and just code it up like that. So, and using doing it by hand actually meant it ran in a very acceptable time, and it just worked. So my lessons that I learned is that you really should know your tools that you're using, be aware of what these libraries do. You know, they tend to be optimized for particular use cases. So in the case of LabPack and the ACML version of it, that was optimized for huge problems. Mine was tiny in comparison, so that's not a good thing. And the other lesson I learned is, so one of my approaches to programming is, at first I try to avoid it because someone else will have solved that problem for me. And sometimes that's just not good enough, and you actually have to do the work. And yeah, so that's my confession. And it took quite a while to figure that out, how to do that. And I've got some details on a blog post with a bit more background, which you can see there. Right, that's me for now. Thank you.
Okay, thank you. It's perfectly to time. If anyone has any questions, could you please put them in Slido, which we've just put the link in the chat for, and we will address those after each panelist has had a turn to talk. So next up, we have Yo.
Awesome. Okay, I have prepared between 1 and 3 confessions, depending on how I feel the time whilst I freestyle without slides. So first of all, I'm just going to talk about a time when I joined the University of Cambridge, and I'd been working in the research group I worked in for about 3 weeks. My colleague had gone on holiday, and I was the other front-end developer, which meant basically I worked on stuff that people interacted with on the screen and click on. And for some reason, it just happened that our web servers were managed by the front-end developers. I don't know why it was the case, but it just was. And my colleague had gone off on holiday, the other front-end developer. And so they said, hey, Yo, we have some problems with these sites. Could you reboot the server? So sure enough, I log on to this server. I spent a little while looking around, hunting down docs. So if you've ever used Heroku, which is a nice online web host effectively that allows you to run certain applications, we had an open source version of that called Doku, which we are running on our own server. And I thought I'd looked up the docs and understood everything really well, rebooted it. I should mention at this point that we had about 5 or 6 sites running on this, including our API documentation that tens of developers from a large community around the world used. And perhaps more importantly, our PI's website was hosted on this server. I rebooted the website 3 weeks into the job. It did not come back up. And one of the most mortifying things you've ever done is go to a senior colleague and say, yeah, I've just broken everything, including our boss's website. And it was so hard to do. Obviously, they were going to figure out at some point, so I had to go and tell someone. But there's definitely a swallow your pride. Hope you keep your job next week and tell someone what's going on. Thankfully, the senior colleague in question, they were really good. They approached us sysadmins, said, do you have backups? Can you help us with this, et cetera, et cetera. And after lots of documentation spelunking is really the only way I can describe it. It's just looking through unclear, mysterious documentation that doesn't quite work with your scenario. I did manage to get these sites back up. My lesson from this is document your stuff really well and don't assume of people's knowledge. If someone goes away and everything breaks, then that is not well enough documented. So I don't feel too bad about it for myself, but it is one of my favorite stories just to introduce newbies and interns. If I have someone like a Google Summer of Code student working with me, first thing I would tell them early on is, if something goes wrong, it's okay to tell me, and then share this story, because it's really useful to know that, like, even destroying everything, it's okay, we will figure it out as long as it's an honest mistake. I think I have a couple of minutes left, so I'll just go into
you've got about 2 minutes.
Quickly. Super. So the next one is about Git. And Git, for those of you who haven't used it, perhaps, is a good version control system. And it keeps everything indelibly on the public record. And that means if you accidentally put stuff in there that you don't want to put in there, that it may still be in the public record even when you remove it. It may just be a little bit harder to find. And so I kept on getting messages from our sysadmin saying, yo, you're over space. You have a terabyte over space. And it's like, no, I know I've never downloaded a terabyte of data. I've never generated a terabyte of data. There is no way. So I just kept on ignoring these silly messages. And then one day they were like, you know, literally coming down and looking at me like, yo, why are you still over quota? So I actually, fine. And I went and I looked and I ran some commands, and sure enough, there it was. That terabyte of database was taken up, like terabyte of folder space. How is this happening? And after some digging, I found out that someone had checked in a bunch of data into a Git repository I'd cloned and then removed it, which meant that I couldn't see it in the repository because old stuff is still in the record, but it's not obviously visible. So I had a terabyte's worth of removed invisible data just hiding there that I'd been clogging everyone's space up for ages, which was really embarrassing. And I have a bonus one. Also about Git and things that are indelibly in the public record is when you are making commit messages where you explain what's been going on, why you've made a commit or a save, as it were, in the version control, check that you don't have typos. I tried to talk about having added a module organism called yeast into the database. I typoed that. The D key is very close to the S key, and the last thing that you ever want to be adding into your Git record indelibly is that something about arse yeast. So I would just share that tweet if anyone wants to have a look at it. It is there. Oh no, that's hosts and panelists only. I'll share it to everyone. If you want to laugh at me and see the embarrassing typos I have, I am done.
Thank you. Okay, could we have Ed next, please?
Yep, I just need to unmute myself and go to the right window.
I can hear you.
Good.
And I can see your screen now.
Excellent. So this is a mistake I made in 2018. So 3 or 4 months after I started working as an RSE, we were given, so our team works on performance optimization. So I was given some 2,000 lines of some Fortran 77 or older. There were some very old bits of Fortran in there. It was currently serial and it was quite performant on one core. The physicist who was working on it had done some work with like Archer webinars, that kind of thing, to do some optimization. So it was performing quite well, but they needed it to be parallel. They needed to go to bigger problems. They needed to get results more quickly as they scaled up. They thought 12 times might be sufficient performance, and our HPC machines have more cores than that per node. So hopefully wouldn't be needed to go beyond a single node. And they gave an example problem that ran in about an hour. And the initial projection for this was maybe it would take about 3 months for an RSE to do this. This wasn't based on any experience because we were a very new team at that point. We didn't have many projects under our belt. So the approach, I took this project on myself, and first thing, benchmark the sample problem with a variety of compilers and compiler options. So we found that using the auto parallel optimization in Intel gave us a 4-time speed up, which was great. That was a really good quick win. We gave that back to the researcher as an interim improvement while we worked on the proper parallelization. Profiled the code with Intel vTune, identified where the hotspots were, and there were 2 to 3 functions that were taking up the majority, 90% of the runtime. So we thought, okay, we need to work on those. And then, you know, we'd heard about OpenMP, how it's really easy. You put some directives around where your code's taking its time, and it makes everything go faster, right? So we spent some time working on that, and then things go south. So this doesn't work. The code starts seg-faulting all over the place, and we can't work out why that is. And we're getting cryptic messages when the application terminates. And then when we stop it from seg-faulting, the code runs more. I'm using the word we, I mean I was working on this. This is entirely my mistake. The code runs more slowly, so it's maybe parallelizing, but it's certainly not going faster, which was the aim of the parallelism. And then it was also at the same time giving the wrong answer at the end. And we had no idea, or I had no idea why this was, because, you know, this is 2,000 lines of monolithic Fortran. So yeah, the project was delayed, and we had to, I had to abandon that month of work. So that was a waste of time. I recovered from this. So firstly, write regression tests for all the functions so we can work out where things are going wrong. Then I tidied and refactored the code a little bit so that I could actually understand what each section was doing while I was working on it, rather than blindly adding directives to it. That I needed to make sure that we didn't lose the readability for the researcher, who is a Fortran developer, doesn't want to be dealing with things that aren't Fortran. And then switched to using MPI to parallelize function by function, because I'm a lot more familiar with MPI, and the researcher was saying that maybe it would need to scale beyond one node at some point, so it would be more flexible in that direction. And in some sense, the way this application was structured, it lent itself quite nicely to MPI parallelism. So then in the end, because I'm leading the team as well as doing this development, I ran out of time to work on it, so I had to hand this over to another team member to finalize. So, and Dr. Michele Mastiti gave a talk at RSECon 2019 about the final version of this. So what did I learn? Don't believe the hype-around technologies. Testing is not optional. You know, you can't cut back on testing. You can't just jump in and do stuff because you're going to waste all of your time. You're going to have to abandon it and go back and write tests anyway. And then also a more management related one, it's hard to lead a team and also keep to a timeline while you're doing software development. And you kind of have to bear that in mind when you're deciding who's going to do what work. How much time have I got, Colin?
You are just coming up to time. You've got about 30 seconds.
30 seconds. Okay, some quick ones I didn't think were worth doing a lightning talk on. I once permanently killed a cluster by using find slash. Talk to people. Don't just do find slash. They can tell you where things are. I have wiped out my home directory by doing rmrf and an environment variable that expanded to nothing. So of course I didn't have backups. Have backups, please, and maybe use set to try and stop that from happening. And this year, actually, I wrote an ON squared matrix routine, which was taking weeks to run, when in fact, if you did it as 2 operations, it went down to O of n, so it only took seconds. So yeah, trying to reduce the number of lines you write to the minimum isn't always the fastest. So yeah, don't be lazy. And yeah, that's me.
Thank you, Ed, for cramming the most confessions into 5 minutes possible. Okay, so next up we have Janetta. Just a reminder that we have the Slido link if you want to ask any questions. And if they're addressed to a particular panel member, can you please put down who they're addressed to? And we do also have a poll running in there about whether you have ever fallen foul of the RM-RF bug that Ed just mentioned. So over to you, Janetta.
So this happened to me many years ago, pre-internet days actually. But I think this is my favorite boo-boo because although it happened to me so long ago, I still remember the panic, and what I learned is still very applicable today. I worked at a company where we developed software for the financial markets. It was a rather weird and complicated infrastructure. We used something called UCSD Pascal, which was running on an operating system called the P system. Most people have probably never heard of this. And this was running on top of MS-DOS, the old Microsoft Disk operating system, which was used on PCs. And then we ran Novell's btrieve database on MS-DOS. Now, I only take partial responsibility for my mistake. And the reason for this is my boss at the time wrote all the libraries that we needed to get access to the architecture's underlying features. So there were some assembler functions and loads of Pascal libraries that would have the P system communicate with MS-DOS and with btrieve, the database. Obviously, my boss didn't document any of these things. So the only way to discover things was in one of 2 ways. You either asked him about it, or you went to the source code of the libraries and then extracted the headers, which would give you an idea of the functions and procedures with their parameters that you could call. And I remember asking him, how do you open a connection to btrieve so that I could get some records out of there? And he told me what to do. So at the time, I had to write a system for the South African Reserve Bank to manage their treasury and land bank bills, which they issued every Friday. So companies would tender a certain value's worth of these bills. Their tenders and the preferred denominations would be entered into the system, and then the tender process closed. When the process closed, the system would automatically do all the allocations, verify and recalculate the denominations, and print out the bills. But yeah, so entering the bills were done manually, but there weren't there weren't many of them. They were usually about 20 or 25, 20 to 25 bills. So this must have worked for about 2 or 3 years. And then I actually left the company for a couple of years. And then I returned to the company. And shortly after I returned one Friday, I get a call that the system is bombing out. So I was a wreck. How can something that's been running for like 4 or 5 years suddenly just stop working and break? So where do I start looking? And so I took the data for the last few weeks and started entering it like they would at the bank, and everything would work except for that specific Friday's data, which you could see what the difference was. And after a while, I noticed that the only difference that there was that for the first time, there were more than 25 entries. There were 27, but the program would bomb out on 26. So I started looking at the code, and under great pressure, because I had to get the code working before something like 2 p.m. because that was when they were supposed to issue the bills to those who won the tenders. So I was pretty desperate. And I called my boss over and said, please help. I can't see what is wrong with the code. And he looked at the code and started giggling and walked away. I said, oh, no, man, come on, what's wrong? So obviously he could see what's wrong, but I just couldn't. I said, what's wrong? What's the problem? What have I done? And what the problem was then, after the tenders were entered, there was a loop in the code that would read the tenders from the database, one after the other. So inside the loop, I would open the database, read the record, and then do whatever needed doing. What that meant to the way things worked in those days was that every time I opened the database, it would open the file in which the database was stored. However, the MS-DOS was by default configured with 25 file handles, which meant it could only open 25 files at a time. And then you would get an error. So I never closed the file before exiting the loop because my boss never told me that there was a closing function, and I never thought about that, so I never asked. So all I needed to do was one of two things: either close the file before exiting the loop, or the better option, of course, was to move the opening of the database to before the loop, then do all the reads, and then close the database. So the lessons I learned is tell your boss to document his code, or people document your code. And we've heard that a few times today. If you open or allocate something, make sure you close or free it. And if closing is not obvious, then you investigate whether there is a need for it. Nowadays, files and database connections are often closed automatically by compilers, and IDEs will give you a warning. But I check it anyway to make sure, because it's just engraved in my brain. Check that you've closed what you've opened. And then make sure that the stuff you put in a loop actually needs to be in the loop. And wouldn't function better outside the loop. You might only need to do it once instead of with every iteration. And then, yeah, it was mentioned test. So I did test very well, but I tested with the data they gave me, and there were always less than 25 records. So test with more than what you are given, and expect that it might go over the limits that you think at some stage. And that's my story.
Okay, thank you for that. That's potentially the most expensive of the mistakes we've had so far. So next up, could we have Becky, please?
Yeah, here we go. Share. Can you see my slides okay?
Yes, it's not in the full screen now. It is. Yeah, brilliant.
Okay, cool. So this is my talk on the right tools for the job. So as I mentioned, I am an astrophysicist, and I study how star clusters are structured. And from that, I try to understand how stars themselves form. And what I was trying to do in this project was analyze the structure of star clusters in a new way, which hadn't really been done before, which took into account the positions of the stars and the velocities of the stars at the same time. And a goal I had for this project that I really wanted to achieve was to make it open. So once I published my paper and published my results, to make the analysis code that did this open so other people could make use of it, and this analysis could become more prevalent. But you know, you may have guessed spoiler alert, I screwed it up. So my mistake was actually two mistakes. So what first thing I did is I used a combination of two programming languages, which you can do, and there can be valid reasons for, as long as you've got something to, get them to talk to each other, it can work. But I screwed it up because one of the languages I used was Fortran 95, as in 1995, which I used to do the hardcore number crunching, because this was a very, analysis intensive thing that needed to be done. And Fortran's fast at number crunching, and I was already familiar with it. And I figured that's fine. I'll put it in a nice, friendly, modern Python wrapper. And then anybody who wants to use this code can just interact with the Python, and the Fortran can do the work behind the scenes. Now, this was a real mistake because it then forced twice the dependency issues on anybody who wanted to use my code like I wanted them to. Because not only did their system have to deal with like having Python all set up, it had to deal with Fortran 95 and have that all set up. And then if it isn't, that puts the burden on somebody who wants to use it to sort that out, which can be a real pain. The other major mistake I made was I had real difficulty getting these two languages to talk to each other. And I eventually got it to work using a deprecated module in Python 2.7. This was at a time when Python 2 wasn't dead, but the time horizon was like Python 3 was going to be the standard in about 6 months. But I figured, well, this is a thing that works, so I'll do that. But again, that was a huge mistake because it meant that anybody that wanted to use my code then had to play archaeologist, finding a niche deprecated module from a no longer current version of Python, roll their own version of Python back, and then maybe it's no longer compatible because things have moved on and maybe the rest of the system around it will no longer play ball, like libraries will have changed and so on. So again, it produces a huge blockage for anybody who wants to use my code like I wanted them to do. And as a result, nobody did. Nobody bothered to use this analysis, and all the time and effort I poured into like documentation and all the other stuff to make this a nice, good, open project people could use was completely wasted because it was just too much of a systematic blocker for anybody to make use of it. It wasn't a total loss because I still did this analysis on my own data and produced a paper. So it's still a valuable bit of standalone research, but it meant that the field didn't have nearly the impact that I wanted it to have. So my main takeaways from this is that simplicity often correlates with efficiency. If what you're doing is this great big sort of tangled mess with things sort of barely bolted together with duct tape, you're probably going in the wrong direction. It's better to use a small set of tools that work well together and small as possible. And the other thing is the convenience of using something deprecated now, even if it does the exact thing you need and you're really struggling with it, unless you're doing something really quick and dirty that you know is going to be a one-off, it's just going to bite you twice as hard later. Do the work now, even if there is something, because the problem's only going to get bigger as time moves on and it moves further and further away from current. So take the hit early is my advice. So yeah, my final takeaways from these mistakes was to really think and make sure I'm using the right tools for the job, to try and keep those tools as few and compatible as possible, and to keep everything current, even at the expense of earlier, at my current time resource. So yeah, that's thank you for listening.
Right, thank you for that. There's definitely some good points there, and several I can think of that I've made myself. Right, so now we are on to Graham.
Right, thank you. Let me start sharing this thing. So this is about how you manage to break absolutely everything. And it involves localization, which is a weird way to break absolutely everything, but trust me, I managed it. So the way that localization works on a Mac is that the user has a list of the languages that they would prefer to use their computer in, ordered by preference. And then each application has a series of localization projects which contain the UI in different languages. And in this case, while the user would prefer to use Danish, the app doesn't support Danish. The user's second choice is German. The app does support German, so they get German rather than English. And that works across like the Mac operating system. It doesn't work for the root user because, as we can see here, there is no root user on a Mac, or rather there is, but the account is disabled. No one ever logs in. So no one has ever set the localization preference. It's for the root user. Now, I was working on an enterprise antivirus application, which probably if you work in a university, like your IT department has deployed onto your computer. And the log system, like all of the log files are primarily for the customer, for their IT department to understand what's going on their computer, and secondarily for us. And that meant that the customers wanted the logs to be localized so that their sysadmins could read them in their preferred language. But we don't know what the preferred language of the user is. Well, there's a little like hack we can use to get around that, and that is that when the sysadmin ran the installer for macOS 10 to set up the computer, it wrote a log file that explained what language the user had chosen when they ran the installer. Now we can make the assumption that the language that they want then is the language that they would like to continue using. And indeed, most of our customers were happy with this until one point around 2008, I think this was, someone told us that this wasn't working. So we asked for some diagnostic information. They said that the logs were coming out in English, despite the fact that they had that they were using a different language on their computer. So we got we asked them for their copy of this file, and Apple had changed the format. Like it now contains these two-letter ISO language codes rather than the name of the language. That's it. That seems like a simple enough thing to fix, right? So I go in and I apply all of my favorite software engineering practices. So I start writing unit tests for, like, if the language is German, does this work? If the language is DE, does this work? If the language is something else that we don't support, what happens? If the file doesn't contain the language at all, what do we do? And then an integration test to show that if the language is set in one way and you install our software, then then the log files for the antivirus come out in the preferred language. But all of that worked. I also noticed that we used this code in 3 places. So the report had been that the on-access scanner for the antivirus wasn't logging the correct language, but we also used it, and this becomes important later, in our auto update daemon and our remote management daemon. So we had 3 copies of this code, which was in C, and I replaced all 3 copies with a single shared library that was fully tested, had passed code review, had like unit and end-to-end tests. Everybody's happy. Like, Graham has applied all of the software engineering skills that we talked about from the industry practices talk at the beginning, earlier in the conference, right? Wrong. Customer comes back with another, it doesn't work. Well, what do you mean by it doesn't work? Okay, the on-access scanner isn't running at all. This is even worse than it is logging in the wrong language. What we found was their computer didn't have this installer log file. No one had ever run the macOS 10 installer on this Mac. And so we didn't have this file. I hadn't accounted for the fact that this file might not exist. And so the program ended up with a null pointer where its localization table should be. The first time it tried to write, welcome to our application copyright 2008, our company limited, in the target language, it fell over. Well, that's okay, because now that we understand it's a really easy situation, we can fix it. We can release a patch that addresses this problem. Now, how do we get that patch to the customer? Because you remember, I said that this was a shared library, and I had used this code not only in the on-access scanner, I had replaced it in the auto updater as well, which meant that their auto updater probably wasn't running because it had also crashed the first time it had gone, welcome to our auto update service. I am running correctly. So we couldn't just release it to a website and allow for their thing to regularly update. We also can't get them to remote deploy it because remember, the third place that we were using this code was in the daemon that does the remote management agent. And so the remote management agent isn't listening for commands from the dashboard either. So there's basically the only thing that is left. The only possible way to update this software is to manually go to the computer and apply the update there. Now, what kind of company or what kind of sysadmin do you think is the kind of sysadmin who didn't run the installer on the Mac? It's the one who has lots of Macs, and so they use a system imaging software, which is why they never ran the installer, is because they actually just copied an image and that image didn't contain this file. So this customer who reported this had like 120 Macs on in one office, but basically every customer with a large deployment would find that they now had to physically go to each computer that they owned and manually run the updater locally at that computer. So a lot of CDs were burned, a lot of customers were apologized to, and I would like to admit at this time that, hello, my name is Graham Lee and I inhabit Clowntown. What we learn here is that it doesn't matter whether you're using the practices. What you have to do is know whether you are actually solving the problem that you have. So thank you.
Right, thank you for that. Okay, so now we have time for questions, and I see we have quite a few questions that have come up in the Slido, which I presume is just appearing on the screen. Yes. So one thing I'm amazed at is that 30% of people here have never had an RM-RF star type bug, or perhaps don't want to admit it. But could we see the questions? Okay, so I think we'll take these in order of the number of likes they've got. So the first one, I think this relates to Ed's talk, but probably others as well, is how did you persuade your boss, PI, researcher that it was worth spending time adding regression tests, cleaning up the code, etc., etc. So I don't know, Ed, do you want to kick us off with an answer for that?
Yeah. So I was in the relatively fortunate position that our team was externally funded to do this kind of work, to do performance optimization, and we'd reached the conclusion, yeah, we can't do this without doing some cleanup, adding some tests. So if you want this done for free, then you need to let us do this, and it will add some time, but you will get something that is better than in a better state than we received it in, and does the things you need it to do. So yeah, if you're working as an integrated RSE or funded by the project, then that becomes a more difficult discussion to have. But I think it's this, it has to be the same argument that I don't understand this code. I have no guarantees it's giving the right answers. And if I start working on this without that guarantee, then I'm going to make things worse, not better.
Okay, does anyone else from the panel want to add anything to that?
Yes, I think there's going to be a session on Monday where we're going to discuss exactly that, if it's worth testing, and yeah, definitely. So.
Perfect. Shall we move on to the next one then? So how can we?
Sorry, Colin, I was just going to come in on that one as well. I think you can also start from a position of just, when you're giving your estimate and when you're writing into your grant app, like how long you think it's going to take, just assume that you're going to use best practice. Like, don't even get to the point where you're asking permission to do the right thing. Tell people how long it will take for you to do the work, and then if that's a problem, negotiate from there.
I don't know about you, but I always find it so hard to get that estimate right, even when I know I need to add on time for that best practice.
Yeah, well, they're also like make sure to pad the Scotty approach to engineering.
Yes. Yeah, Yo's just said in the chat, another good one is just do it, don't ask, and then enjoy reaping the benefits later. And Ed said Hofstadter's law, it always takes longer than you think, even after taking Hofstadter's law into account. Yes, I definitely find that. Okay, should we move on to the next question then? So how can we make it easier for RSCs and researchers to know what is the right tool for the job? People don't know what they don't know. I'm not sure who's best to start that one. Does anyone want to volunteer?
I'd say a hard part of it is, is that it's part of a thing that comes from experience, like particularly with the example I gave, it's kind of that instinct of if you're strapping everything together with duct tape, it's about knowing if you're using an efficient tool, because if something isn't precise, you can kind of get that instinct of I'm heading in the wrong direction, which just sort of comes with time, which mentorship can be really helpful, talking something over with somebody. If you're having a real difficulty explaining what you're doing, you're probably not doing it in an efficient way. Other than that, in terms of just knowing what tools are available, also talking to people, mentoring and all the rest of that is helpful in that respect, I think, as well. So yeah, I'd say I
think those 5-minute conversations over coffee can then save you many days of work.
Yeah, exactly.
Yeah, I think I was going to say something very similar, and I think knowing what tool to use is an experience thing, and you gain that over time. You make lots of mistakes, and that's how we learn, really, through making mistakes, and then adding that to our list of things not to repeat. And to help others, I think you just need to talk to people and talk about your approach to solving a problem, and they might say, well, yeah, but have you tried something else or whatever? So I don't think there's a shortcut, really.
Come to SeptembRSE and hear about everyone else's mistakes.
Yeah, I think you had your hand raised. Did Becky's answer cover you?
Pretty much, yeah. No need to.
Okay, should we move on to the next one then? Do you think more people would write documentation if it was refereed, published and cited like a paper? Why code review but not documentation? Any volunteers to take that one? I see Graham and Yo have got hands up. Is that volunteering or are they left from before?
No, I'll volunteer, but I'll let you go first.
Thank you. I think this is a great question, just because personally, my experience when I'm reviewing code related to papers is that documentation is often forgotten if it's not required. I think it's great every time a publisher says make sure you link to your code on GitHub or wherever it may be, but then if you click through in the GitHub, it's like, unless I know it really well, I don't have the recipe to make this code run, and I'm going to have to do some good guesses. And I think it should be, running docs should be a bare minimum, to the point where in my day job where I work at the Wellcome Trust, we have in a few scenarios recently where we've had grants. In the grant conditions, we've said that as part of this, when you are writing your software, there needs to be running documentation to tell us how to run. Now, then you get in the question, or how much running documentation is enough running documentation? And that is a very big, deep hole I cannot possibly go into right now. But I can be certain that some is going to be a lot better and a lot less painful than none. And that is something we absolutely should require as a minimum.
Yeah,
sorry.
Oh, sorry, go ahead.
Okay, so what Yo said was absolutely spot on, and like what I would expand on is that the audience for documentation isn't necessarily the same as the audience for a published paper. That the sort of review and publication and citation process for the paper itself is the way it is because it's grown organically in that context, and what we do for documenting source code is much lighter weight than that, but we're potentially writing for other people. I think it is absolutely right to say that if the code is a significant artifact of the research, then it needs to be appropriately archived to decent metadata, which includes a documentation to reproduce the research that is being published. But a lot of software is being written for for other developers to take on and use, or for end users to install and run on their own computer, and that what is needed in that context isn't the same as is needed for a published paper.
Okay, Becky, you had your hand up. You're muted.
Thank you. I was just going to briefly say that because there's been sort of more of a push towards making software citable and recognizing software citations as just as valid, I think that's a huge advantage. But I would say software is going to be reused if there's good documentation, because if the software is publicly available, nobody can make use of it, then it's not going to get those citations. So I'd say it's kind of like good documentation is kind of folded into those citations, essentially. So I'm not sure. I don't personally think making documentation itself citable, separate from the code, like the whole code repository citable, would be a huge advantage from my perspective.
Okay, there was a good comment from Sarah in the chat as well about not merging pull requests that don't have documentation, that documentation is a required feature before you merge. But obviously that only applies to larger open source projects where you're taking merge requests from other people. Right, shall we move on to the next question then, which was from James? While many mistakes can be avoided, mistakes are sometimes unavoidable, even using best practice. What are good ways to fix mistakes after the event? So any volunteers for that one? That's quite an open-ended one. Yo, you've got your hand up.
Honesty. Hi, sorry, I've screwed up. What do we do next and how do we fix this? No blame, because we know going into this that we've done the best we could at the time, probably. And if you have blame, people are less likely to own up, to want to talk about it, to want to fix it, and a review of what happened. So if we've had it, what can we do so that it doesn't happen in the future? I think it's just deal with it. Like be really, okay, it happened. How can we make it better? And just be really like super calm, super happy is the most important thing here.
Yeah, I think that's really vital. Right, Magnus, you had a hand up as well.
Yes, I was going to add to that. Yeah, there's no point blaming anybody because making mistakes is quite normal. And I guess if you do have some form of testing framework, you add a set of tests that check for this sort of problem, so that it's a thing that's ticked off and can't happen again.
Yeah, definitely. I always wonder how much of these mistakes, although it may be one person who you can blame at the minute it happens, how much of it is a sort of system-wide symptom because you've had many people contribute to get to that stage and to allow that mistake to happen and filter through your process?
Well, I guess just thinking about my experience, it depends also what sort of mistake it is, because some mistakes arise from sloppy practice, and then you probably have to tell that person, look, you need to get a grip and be a bit more organized, and then, well, hopefully, or try to do that in a supportive way, and yeah, but I guess that can also happen.
Okay, and Graham, did you want to add a comment?
Yeah, thank you. I wanted to amplify what you said, because I think that's a key point. That, like, while you may be able to find a person who initiated the thing that caused the problem was systemic. Everything that was going on allowed that problem to get all the way through the system and into production or into the publication. And so it's important to sort of say collectively, we allowed this to happen. What are the things that we can do that change our processes or our practices that mean that we're not vulnerable to this kind of problem in the future, or that the damage is lower? It may be sort of speeding up the delivery pipeline so that updates get out faster, so that you can fix a problem, or it may be like changing techniques so that the problem is less likely to be introduced. But it is definitely an us problem, not a you problem.
Yeah, just thinking about that further as well, there's a culture in some places, and especially you hear this in senior government levels, of firing the person who immediately appears to be blamable, which I also think is the worst thing you can do, because they're the person who now knows that mistake and isn't going to repeat it. Anyway, shall we move on to the next question, which was for Ed? And do you think it's possible to lead a large RSE team and still work on projects and do coding yourself?
I think the difficulty scales with the size of the team. So in the project I was talking about, we had a team of 5 people, 2 of whom were senior RSEs and so had line management and managerial responsibility. But the way our job descriptions were written, we also needed to be doing RSE work in addition to managing and doing paperwork for Welsh Government. So it was kind of feeling the obligation to try and do some project work. I think as teams get larger, even at that point, the team was large enough that there was enough management and other coordination work that it was getting hard to be the sole developer. I think if if you're contributing as part of a team, you're pitching in, but you're not the sole developer or necessarily the lead developer, I guess, then it's more possible. Alternatively, if you're working on things that just don't have a deadline, where you can just drop it for a couple of months and come back to it when you have some time, or you're doing things that you can complete in an afternoon, those are the kind of things that I use to keep my hand in while also leading a team, and so not having time to take on entire projects to myself. I'm curious, does anyone else have anything on that?
Stunned silence there. Okay, I think we're almost out of time. Maybe we can very quickly take the final question on, do you think IDEs and toolings have helped you make fewer mistakes, and should we encourage more researchers to use IDEs? So Graham, I think I saw your hand go up first, and Yo's very quickly after that.
Right, nice. I'll be quick but contentious. I think probably the sorts of problems that IDEs were designed to fix are problems that we no longer have. So, you know, they do a lot of sort of support with like getting syntax correct, and, you know, but doing refactorings and remaining in a state where you have correct syntax. Well, we also detect and report compiler errors a lot earlier in the process than used to happen. You know, you used to like run your C++ compiler, and 15 minutes later it would spit out an error. And that's the kind of thing that an IDE is helping you detect. I think like there's a lot of problems, domain problems, missing tests, missing documentation that we talked about that an IDE isn't going to help with.
Yes, I think I'd broadly agree with that. Yo, I think your hand went up next.
Just super quickly, I maybe an unpopular point of view as well. I avoid anything like an IDE or autocomplete because the likelihood is that I won't remember a function name if something else types it for me. And I find it a frustration and irritation that it makes it harder for me to actually know my code when it is trying to autocomplete and hop me around loads of different things. The one exception is Java. I cannot do Java without an IDE.
Okay, Magnus, that was next, I think.
Yes,
we're now running out of time.
So I was going to say exactly the same. Like, I really don't like IDEs. They get in the way, and I think you at some stage you need to have an idea of how your project works, and obviously depending on the size, that's more or less tricky. And if you've got a huge project, then yeah, an IDE will help you navigate it. But I don't think it really helps you avoid problems.
Did anyone want to defend IDEs?
I didn't want to defend IDEs, but I want to defend tools. So I'm not an IDE user, just because I've never got into that habit, and because I work across different languages. So different languages work with different IDEs. But I think using tools that integrate with whatever editor you want to use can be really powerful. I don't use autocomplete because I haven't found one that works for me. But things like inline linting, Graham was talking about compiler errors, and certainly you can go to the compiler and run things and get the errors back. But I find it's a much quicker cycle to have it there not the IDE, sorry, but in my editor, having it linted, and then also using exactly the same mechanism, it will point out to me if I've forgotten a doc string or that kind of thing. So it does help with that as well. So yeah, I'm a big proponent of finding tools that remove cognitive load, because these are just sources of cognitive load that mean I'm distracted from the things I'm trying to do with the software, and having that tidied away so I can focus on other things is really useful. And it means I found since I started using I use flycheck in Emacs, and since I started using that, I've written tidier and better code, and I've written it more quickly. So
I see there's some love for VS Code in the chat. Right, I think at that point we are out of time, but if anyone would like to continue this discussion, we have a poster up in Gathertown at P1015, and we also have a space there where you can add your own coding confessions onto a Google document. There is also our Coding Confessions blog, where we will write up everything that we receive, both from the panelists and from you on that form, which is one I've just pasted in chat, but currently we just have one confession live on there, but hopefully many more in the coming weeks. Right, and just like to thank everyone who has contributed to this, and all panelists especially.
Absolutely, I learned a lot. Thank you for sharing your mistakes and your confessions. That was really, really cool to listen to.
Thanks, folks.
Thanks, that was really good fun.
Thanks.
Thank you. See you.
Thank you. Bye.